Fine. So what is a mixture basically? Quick point with revision here. What is a mixture?
We talked about how they're like solutions mixed with a solvent and a solute.
Hmm. Basically, we can have the mixture as anything in which two or more than two pure substances have been mixed together in a variable composition without any chemical bonding between them. Yes, that is a
Yes.
mixture. So therefore, solution is a type of a mixture. Solution is a type of a mixture which has a solute and the solvent. We can have other different types of the mixture also, right? Like the suspension, the colloids, all of these different things. Okay, so that's a mixture. Now we can see so let's suppose I have A and B in a mixture and I get C. This is a mixture. If I want to separate the components of A and B here from this mixture C, what are the different methods that I can use based on the different types of the mixtures and based on the different components of the mixture? Okay, that is what we are going to study here. Yes.
Okay, miss.
Okay. We can see this in the processing of the crude oil, in producing fresh water from salt water, and in the enrichment of uranium. Forensic science. In forensic science, the components of a mixture usually have to be separated before they can be analyzed. Fine. Okay. What happens? How do we get the salt? What's the basic method to get the salt?
Um, Acid plus metal is salt and water.
That is true, but how do we get it on the industrial scale? Is that through
Um,
the seawater, right? Seawater is seawater a source of salt, Bachcha?
yes.
Yes. And how can we, if seawater is the source of salt, salt must be dissolved in the seawater, right? And that we need some method to separate out that salt from that seawater. And what is that method?
Simple distillation.
Simple distillation. If I say leave everything, can I go for simple evaporation? Water being liquid will
Yes.
evaporate out and only salt will be left behind. Yes. So this is one
Yes.
method. Always remember one thing, that since in the mixtures, the components of the mixtures are bonded physically, we just need the physical methods of separation. There is no need for the chemical methods of separation. We have already discussed this. Example, if you want to separate the components of a compound which is chemically bonded, we'll be using electrolysis, example for water, which is a chemical method. Here, evaporation, filtration, distillation, fractional distillation, crystallization, all of those are examples of physical methods of separation. Fine. So we are using different methods. First one is the filtration. First one is the filtration. Okay.
Filtration.
See, the condition is when we have a heterogeneous mixture. When we have a heterogeneous mixture and with a large particle size. Large particle size. See, in the last class, I discussed what do we mean by stable and unstable mixtures. Yes, Bache? What do we mean by unstable mixtures?
I don't remember, miss.
Unstable mixtures, let's just imagine the case of sand and water. Okay, if you mix sand and water, that becomes a mixture, right? That is a mixture, first thing. And when you mix the sand and water, if you are mixing them properly, they will appear in a mixture form. But if you leave that mixture undisturbed for some time, Soumya, don't you think the sand particles will actually settle down in the bottom of the beaker and water actually will come over the sand particles, something like this?
Yeah.
Yes. And this is simply what we used to learn as sedimentation and decantation. Yes. And then when we have this type of the mixture wherein one component of the mixture settles down at the bottom of the container, okay, we can filter that out. We can filter that out. Yes.
Yes, miss.
The other component will be filtered out, and that is when we can use the method of filtration. See, sand can be separated from water by filtration. The apparatus of filtration is this. Simple. No, the substance in the left in the filter paper is called the residue. What will be the
Red.
residue in sand and water?
The residue would be salt
Ah, where has the
in
salt come
salt
from?
water.
Sand here, right? Right. And the filter
Oh,
will be the water. Yes.
okay, miss.
Yeah. Filtration
This
can also.
is for substances that don't dissolve.
They dissolve, but they are heterogeneous with a large size, particle size. Therefore, they are unstable mixtures. You understand unstable?
Okay. Yes, miss.
Yeah. So basically, when you are leaving them as it is undisturbed for some time, the components particles separate out in the container in the beaker itself, and then we can separate them out. Okay? Is it okay with you?
Okay.
Fine. Moving on to the next. Any problem here?
No, miss.
Second, what is crystallization? I just see this thing. Filtration can also be used to separate two solids from each other if one of them is soluble in water. We will see the example of rock salt. Yes. How can we separate this? Let's suppose
Um,
we have two solids. We have two components of the mixture, both of them being solid. Okay. And if I mix
okay.
water in this mixture, if I mix water, okay, and B is soluble in water. B is soluble in water. Don't you think A will be here settling down because A is not soluble in water? And here we will have B, which is already soluble in water, so that will be in the aqueous form. Therefore, if I filter this out, I will get A as the pure A here, which is the residue, and
Yes, miss.
I will get B in the aqueous form, which is the filtrate then. Okay, fine. Moving on to the next part. That is the crystallization. What do we mean by crystallization, Soumya? What is the concept behind crystallization?
It's a
See,
separation method.
yeah, that is the separation method. See, do you know something about the saturated solution?
Yes.
What is it? Good.
It's the maximum amount of solute dissolved in a solvent.
Excellent. At a particular temperature, right? At a particular temperature. So let's say if we increase the temperature, we can add more solute, right? But if we decrease the temperature, the extra solute which is there for which is, let's suppose, at 5 degrees Celsius temperature now. Earlier we were having 30 degrees Celsius, okay? So 30 grams of the solute was soluble. That was making the solution saturated. But now if I have the temperature at 5 degrees Celsius, okay, don't you think only 10 gram of the solute will make the solution saturated? So therefore, where will the 20
Yes.
grams go? It was there in the solution, but now it will be left out. So therefore, it will crystallize out. Okay, it will crystal. Okay, it will form the crystal or it will precipitate out. It will crystallize or it will precipitate out. Okay, so there, that is the concept here. Can be used to separate a solute from a solution. Separate sodium chloride from a sodium chloride solution. From a sodium chloride solution. Here we are talking about the mixtures which are in the solution form. What is the solution form? The homogeneous form. I hope you're not getting confused.
Yes, miss, I understand.
Fine. So basically, if you want to, in simple words, if you want to, separate the solute from the solvent, from the solution, we can use the crystallization method. And what is the concept here? If we decrease the temperature, the excess of the solute will actually precipitate out or will form the crystal, and then we can filter that. Then we can filter that. See, the solution is heated in an evaporating basin to boil off some of the water until an almost saturated solution is formed. This can be tested by dipping a glass rod into the solution. See here what is happening. Let's suppose we had 100 ml of water, okay? 100 ml of water, fine. Now if we have boiled some of the excess water, definitely the saturation point will also reduce. The amount of solute soluble in that will decrease, yes or no, Vache? If the volume of the water has been decreased.
Um, the amount of crystals will be the same.
No, I'm asking, let's suppose I had 100 ml of water, okay? I had 100 ml of water, the solvent. And in this, I was able to dissolve 30 grams. But now if I boil off some of the water, definitely the now only 20 grams will be able to dissolve, right?
Um, I don't understand, miss,
Okay.
how that works because there's the same amount of solute.
Yeah, that's what I'm saying. If there's the same amount of solute, but only 20 grams will be soluble because we have, decreased volume of the solvent. So therefore, 10 grams will actually precipitate out, will form
Okay,
the
miss.
crystal. Understood?
Yes, I understand now.
Fine. The crystals can now be removed from the mixture by filtration. The same method as we got there in the first step. The first method, that was the filtration. So what is the difference in the filtration and the crystallization method? The filtration is used when there is a heterogeneous mixture or the components are not soluble into each other. are not soluble into each other, okay? But when we have the crystallization method, we use it for the solutions which is homogeneous mixture. So we actually crystallize the solute, and then we are able to filter the solvent and the solute. Clear?
Yes, miss.
Fine. The next one, rock salt from making pure salt from the rock salt. How can we do this?
We
What can we do
can
here?
crystallize salt.
How?
Crystallize
How?
by heating the solution.
If you correct the rock salt and mix it with hot water, the salt dissolves, right? But let's suppose this is salt and it is having A plus B plus C impurities along with it, right? We just want to get this salt. We just want to get this salt. So when I dissolve this in water, the salt will be soluble, the salt will dissolve,
Yeah.
and then A,
Yes.
B, and C, we will be able to filter salt and A and B and C separately, right? Once we have gotten the salt solution now, we have gotten what? The salt solution. Now this is the homogeneous mixture. Now I need to separate the salt from the solution form. So can I crystallize it now? Can I crystallize it?
Yes.
Yes. Or the second method is I can actually evaporate it. I can evaporate it. The water will be, evaporated off. We'll only get the salt here.
Yes,
Hello.
miss.
Okay, fine. The impurities can be filtered off and remain on the filter paper. The filtrate is then a salt solution. Salt solution means salt plus water. We still want to, have the salt from that salt solution. That is our point now. The solid salt can be obtained from the solution by crystallization. Okay, typical way that you separate it. Any confusion in this, Soumya?
No, miss.
What is distillation? What is distillation?
Distillation is a separation method which
Hmm.
involves one component of the solution being heated to produce another.
Yeah, the only thing is that let's suppose we have a salt solution, okay? Any solution of the compound. If we are separating this here, what we are able to do, we'll get the salt and water. We will get salt and water from this solution. Okay, salt solution,
Um,
salt and water.
yes.
In the distillation technique, what is the main purpose is that instead of wasting water, we are able to have the water also in the pure form. Okay, that is the only point. That is the only point here. See, can be used to separate the components of a solution. Again, a solution. What is solution? What type of a mixture it is?
A solution.
Homogeneous. We can use crystallization to separate sodium chloride from a sodium chloride solution, the salt solution, right? We can also collect water if we use simple distillation. The same point here, when we were using the crystallization technique, we are not able to collect the water from there. Yes, because we are boiling it off. Yes, Soumya? Here, what we are
Yes.
doing is that we want to collect that water also, but we want to have both of the components in the separate form. The components of what? The components of the salt solution. The components of the pure salt solution. So therefore, what do we use? We use the distillation method. The water boils and is condensed back. Simple. In the crystallization technique, let's suppose we are boiling of water, right? Evaporating. They are in the vapor form here. We get the pure salt. We get the pure salt. Why? Because it is crystallizing. Yes. The only thing if I'm doing here is that if I am able to condense these vapors back into liquid, don't you think I'm getting pure water here, separated from the salt solution? And also I'm able to get the salt here.
Um,
Okay,
yes.
I'll explain it. Any problem? I'll explain it. Just a second. What we are doing in the crystallization method, look here. Let's suppose, bache, I have water here plus salt here, okay? This is present in the mixture form, okay? How am I able to remove both of them from each other? I am evaporating this water, okay? Evaporating means I am having the water in the vapor form, yes? And the salt is forming the crystal, yes? In this manner, I am able to separate both of them,
Yes, miss.
yes. But now, let's suppose the only thing extra that I'm doing here is that if I'm able to condense these vapor back into liquid, condensed to liquid water. I'm also able to get the salt here and also the water back. Yes or no?
Yes, miss.
Yes. So what is this? This is the simple concept of distillation. What happens, Somna bache? Why so low? All good?
Yes, miss.
Chemistry has started to bore you?
No, miss, I just woke up from a
Huh?
nap before that,
Or the
so I
chemistry
was.
teacher has started to bore you? Be
No,
honest.
miss.
Okay, fine. So that is the only difference here between crystallization and simple distillation. What is the difference? In case of crystallization, we are boiling of water, we are not able to get the water back. Whereas in case of distillation, we are also able to have the water collected in the liquid form by condensing the vapor back to the liquid form. Fine.
Yes, miss.
Okay. We get the water, we are able to condense it here. We get the water, the vapor form. We are able to condense it here, therefore we get the pure water. Also, we get the salt here in the crystal form from this salt solution. Okay, see, from the diagram we can understand it. This is the sodium salt solution. What does that mean? It will have the salt in the water. It will have the salt in the water. We started heating it. The water will evaporate. The salt will crystallize. The water will evaporate. The salt will crystallize. Okay. Water is then condensed, and here we get the pure water. Simple. Any problem here?
No, miss.
Now, fractional distillation. What is fractional distillation? Hmm.
It's like a method used to separate two liquids.
Two liquids. What type of liquids are there?
Liquids with a different boiling point.
Huh? Different boiling point. But what type of liquids are there?
Like an an alcohol and water
What have I written here? Hmm.
mixture.
Miscible.
Oh,
Huh? You will say that, ma'am, it is miserable. No, it is actually miscible. See, what do we mean by miscible liquids?
I'm not sure, miss.
Okay. Immiscible, miscible liquids. See, miscible liquids are those liquids which have mixed into each other very clearly in a very homogeneous manner. What manner? In a homogeneous manner. Example, if I mix water and oil, they will actually form different layers. That means they are immiscible to each other. That means they are immiscible to each other. Whereas if you must have seen the petrol, I mean not seen but at least read about it, okay? The petrol, the black liquid that we get. Okay. In this petrol, it is a miscible liquid having many different organic compounds. It also has a petroleum. I've written the wrong thing here. Petroleum is the one which we get. Okay. We have the petroleum. Okay. It also has a diesel. It also has a kerosene. Yes. It also has the bitumen, all of that, the wax, all of that. But it is a miscible liquid. We are not able to see in the petroleum itself that what are the different liquids which are present in that. Yes, that is why it is a miscible liquid, mixture of miscible liquid. Now, if we want to separate these components from the petroleum, how can we do that? How can we do that? We cannot really use the filtration method. Why? Because they are homogeneous. We also cannot use the crystallization method. Why can't we use the crystallization method here?
Because there's no solute.
Yeah, excellent. There's no solute in the solid form. Therefore, even if we actually have the heating part, okay, both of them will actually evaporate. Both of them will actually evaporate, and that is not we want to do. And because of the similar reason, we cannot also use a distillation method. Therefore, we'll be using we'll be using the fractional distillation. Now, what is the concept of fractional distillation, Soumya?
It's when you evaporate the substance with the lower boiling point into another tube, while one of the substances remains.
Excellent. So basically, we are having the concept of different boiling points. Yes, different boiling points. Let's yes. So different boiling points. Okay. Now let's suppose we have A, B, and C as a mixture. A and B and C as a mixture. I have the apparatus here. I heat them. Okay. Now all of them will actually convert to the vapor form. Actually, all of them will convert to the vapor form. Okay. Yes or no?
Yes.
Okay. All of them will convert to the vapor form. Now all of them will start going upwards. All of them will start going upwards. Now let's suppose as they move upwards, don't you think they will start losing the energy? They will start losing the energy. Yes or no?
Yes.
So they will want to convert back to the melting, this thing, the liquid form. They will want to convert back to the liquid form. Yes. Now the compounds, let's suppose C has a higher melting point. C has a higher melting point. Therefore, it will actually change back to the liquid form at higher temperature. And A and B has lower melting points. Okay. So let's suppose C comes here. It loses that much of energy, which is able to have enough high melting point here for C. At this temperature, covering this distance, the C will have the energy which is enough to change it to the liquid form. So it was in the gaseous form here as a mixture. Now C, but since it has lost the energy, C will change to the liquid form here. We have separated C. We have separated C from the mixture of three of them. Yes or no?
Yes, miss.
Is that understood or not?
Yes.
No. Let's suppose B comes here and at this point it has enough energy, okay, which is like it will change to the liquid form. So here B changes to the liquid form. It will separate out. Why? Because A is still in the gaseous form. Okay. So A comes here, and it will lose the energy for this much of distance. Why? Because A had a lower melting point. A had a lower melting point. At this temperature, it will change to the liquid. All of the components of the mixture have been separated.
Yes, miss.
Is it understood?
Yes,
No.
miss.
Any confusion here?
No, miss.
We'll go through the book so that it is clearly understood. See, is used to separate a mixture of liquids such as ethanol and water. Why? Because both of them are miscible to each other. Ethanol and water are completely miscible with each other. That means you mix them together in any proportion and they will form a single liquid layer. I think that would have been understood. You can separate them by taking advantage of the different boiling points. Water boils at 100 degrees Celsius or ethanol boils at 78 degrees Celsius. Now, what would they do? Let's see. Both liquids boil, but by carefully heating, you can control the temperature of the column so that, see here, what are they doing is that the same concept, but they have just told it in a different manner. Let's suppose they have two components here, the ethanol and the water. Okay, ethanol will boil at what temperature?
78.
78. So let's suppose they have 80 degrees Celsius as the temperature. Water is still in the what form? The liquid form. The ethanol will form the vapor and it will condense. The ethanol will form the vapor and it will condense out. Water is still there in the what form? The liquid form. Is it clear or not?
Yes, miss.
Condenses in the column and trickles back into the flask. Only the ethanol remains as. Or, just a second. Yeah, that both liquids boil, but by carefully heating, you can control the temperature of the column so that all the water condenses in a column and trickles back into the flask. Yeah, the boiling this thing. Water will boil at 100 degrees Celsius. So we'll be able to separate out the ethanol first. Just a second. Some confusion. Both the condensation. See, that's the same thing which we were discussing when I was explaining it here. Water will actually change it into the gaseous form, okay? The ethanol will also change into the gaseous form. The temperatures will be maintained, and if water is in the gaseous form, let's suppose the temperature comes back to 80 degrees Celsius. The water will change back to the liquid form. The water will change back to the liquid form. Yes or no?
Yes, miss.
Yes. And it will condense out. It will condense out. In what form? The liquid form. Yes. But the ethanol is still in what form? The gas. Okay,
Okay.
that's the simple point. Okay, so the way to the ethanol will remain in the vapor form and it will come out. Why? Because water has already come back to the liquid form. Why? Because the temperature was maintained in between so that ethanol still remains in the vapor form, whereas water is able to condense out. Okay. So, any confusion, please say.
No, miss.
No. The next one. Paper chromatography. What is it? Paper chromatography. Any idea about this?
Yes.
What is it? Good.
It is when you have paper in which you draw a
Repeat.
line and then put dyes and you insert it in water and
Hmm.
see the
Hmm.
distance and the RF value.
What is RF value?
It's something lower than 1.
Retention factor. Good. See. Okay. My question to you on this is that what are the two factors that really affect that? What are the two factors here?
Distance traveled by
Mm-hmm.
solvent and
Yeah.
then
What are the two
distance
factors that will affect the distance traveled by the solvent or the dye
solubility
in
in water.
the solvent? Whatever we are taking as the solvent. Okay. Good. And what's the second factor?
Um, the amount of dye used.
The affinity to the paper. The affinity to the paper. That is, see here, paper is the stationary phase, but in chromatography we have two phases. One is the stationary phase. Any idea about this?
Yes, miss. We
Good.
learned it, but I forgot.
Good. Paper is the stationary phase, whereas whatever solvent you are using is the solvent, is the this thing, the mobile phase. Okay, is the mobile. Now, let's suppose we are having these dyes. Okay, these dyes. So there are two things possible. One is that let's talk about this dye. Either it is soluble in this, either it is soluble in the solvent. Yes, either it is soluble in the solvent, then it
Yes.
will not really stick to the paper. And what is the second scenario? It has low affinity towards the paper, which is the stationary phase. The stationary phase means it is not moving. The mobile phase means it is moving, right? If it has more solubility towards the solvent and it has less affinity towards the stationary phase, don't you think it will actually move upward? It will actually move upward. Yes, yes. And if let's talk about this particle or the dye, it has low solubility. Also, it has high affinity for the paper. Also, it has high affinity for the paper. So don't you think it will actually keep on sticking to the paper then and there? So it will not move a very far distance. Yes.
Yes, miss.
And based on that, we will have the retention factor. How do we know the retention factor? What is the
We
what is the hmm,
we calculate distance traveled by the solvent and then the distance traveled by the dye.
yeah, solvent will travel a distance up till the solvent form. That's the maximum distance the solvent will travel. Yes, good. And we'll get the retention factor. Now, how do we know if there's some other dye, if the dye of like the components of the mixture are same or not, based on
Um,
the ratio values
we
of
can
the
compare
retention
the
factor?
R values.
Yeah, exactly. So, any confusion in this one, or should we move on to the next chapter?
We can move on, miss.
You will. Did you go through the questions of the last chapter?
No, miss.
Let's go through that. So, see, the only point is that I know you must be having some other work also, but the only point is that if you're going through it right now, first of all, it will be a revision, so it will actually help you memorize it much more easily, the concepts. And secondly, if you have any problem, you will be able to solve it in a much better manner rather than when you are touching it after a long time. It's all gone.
Yes.
Yes, fine. The atomic structure. This is the most important fundamental concept of chemistry, atomic structure. Now, what idea, first, I would love to know what idea do you have regarding this atomic structure? Then I'll
So
start
an
with it.
atom is what makes up everything, and an atom consists of a proton, electron, neutron. There's like a central nucleus with a proton and a neutron that's orbited by
Mhm.
negatively charged electrons that can leave the particle, and then they can cause covalent bonding and ionic bonding, and the amount
Mm-hmm.
of
Mm-hmm.
protons determine the atomic number,
Mm.
the amount of neutrons and protons determine the atomic mass.
Fine. Fine. So most of it, let's quickly start discussing it. Since you know it, I would want to focus more on where you have the confusion, okay, rather than what you already know. Do you have idea regarding the atomic mass,
Um,
the relative
yeah,
atomic mass,
yes, miss.
the laws of the chemical combination?
Yes, yes.
Fine. Excellent. So we'll quickly. Element, compound, molecule, the difference is clear.
Yes, miss.
So then let me know what you want to study in this chapter, else we'll move on to the next one or the
Um,
main point. Or should I go through each and every point, whatever is your call?
yeah, we
We
can
have
go through.
15 minutes. Fine, fine. Through each and every point, that is what you think?
Yeah.
Fine. So you want the revision. Okay. So element, so let's suppose the atom. Do it here. Is the screen visible to you?
Yes, miss.
Oh no, I have changed the screen. This is the atom. This is the atom. Okay. And what do we know about the atom? Atom is the smallest element or a smallest part of the element which is participating in a chemical reaction. Yes, which has all the characteristic properties of the element. Okay. Basically, we first want to know about the atom. Why? Because it is the atom which is giving different properties, different characteristics, different behaviors to different types of matter or substances. Right. Now, see the structure of the atom. What is the shape of the atom?
Um, like,
Spherical. Spherical shape. Okay. What's the size of the atom?
very, 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 very small.
Yeah, it is. Its radius. We measure the size of the radius to measure the size since it's a spherical body, and its radius is measured in the nanometer. What is 1 nanometer equal to?
One 1,000. Oh,
10 raised to the power minus 9 meter. Okay, very small. Clear? Fine. Now coming on to
yes.
the structure. Atom has got three subatomic particles, namely neutron, proton, electron. Okay, electron being negatively charged. Okay, proton being positively charged, and the neutron being neutral. Okay. The neutron and the proton are together referred to as the nucleons, as the nucleons. Why nucleons? Because both of them are present in the nucleus. Both of them are present in the nucleus. So
Nucleus.
neutrons and protons are present in the nucleus. Now, if I ask you what is the charge on the nucleus, is there any charge on the nucleus?
Yes.
And what is that?
Um, Positive, because neutrons
Excellent,
are neutral, and
excellent.
then protons are,
So
and that's why it
the
attracts the negative electrons.
that is why
It attracts the negative electrons.
excellent. The electrostatic forces between them. So the nucleus is positively charged because of the presence of the proton. Okay. Now the second thing is that electrons are present in the shells of the orbits which are around the nucleus, as you know. Fine. The important thing here is that how do I know the number of the neutrons, protons, electrons in an atom? How do I know that?
You can know about the atomic
Excellent.
number.
Atomic number. How do I define the atomic number as?
Amount of protons in a atom.
Excellent. Number of protons in an atom. Number of protons in an atom. And we know that the atom is initially neutral. What is the nature of the atom? Neutral. It will be having different charges in the form of the electrons and the protons, but the atom is neutral. And we also know that the charge on the electron is equal but opposite to the charge of the proton. Equal but opposite to the charge of the proton. Let's suppose the charge on one electron is -6. Therefore, the charge on the proton will be one proton will be +6, right? So therefore, when we are saying the atom is neutral, what do we mean by saying is that the number of protons will be equal to the number of electrons, so that the positive charge is equal to neutralize is able to neutralize the negative charge. Fine. Now, in the number of electron, what alphabet is used to denote the atomic number? Z.
Um,
Okay.
it's protons and neutrons.
Yeah, I'm saying Z denotes. If I've written Z for any atom, I'm trying to say that the atomic number for that atom is okay. Now, therefore, Z equal to the number of protons in an atom, which is further equal to the number of electrons in an atom. Why? Because the atom is neutral. Because the atom is neutral. Now, the number of neutrons. How do I get to know the number of neutrons?
Um, it's the uh, mass minus the proton number.
Mass number. Good. Excellent. Mass number. Okay. Mass number minus the protons I will get as neutrons, number of neutrons. But my question is, why am I taking the mass number? And why is only, why mass number is having contributions only from the proton and the neutron? Why not from the electron?
Because the electrons doesn't differ. It's not in the nucleus.
See, let's suppose, but the point is, I take the mass of one neutron, I take the mass of one proton, and I take the mass of one electron. Okay. The mass of one neutron and one proton is almost very similar, 1.6 something something into 10 raised to the power minus sorry, kg. Okay. Whereas the mass of electron is very, 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 very small into 10 raised to the power minus 31 kg. You can clearly see that the mass of electron is almost negligible in comparison to the mass of the neutron and the proton. The mass of the neutron and proton is almost equal. Therefore, we neglect the mass of the electron while taking the atomic mass, while taking the mass of the atom. The mass of the electron is almost negligible when we are accounting for the mass of the atom. Therefore, we say the mass of the atom is only represented by the neutrons and the protons. Therefore, we say the mass of the atom is only because of the presence of the number of the neutrons and the number of the protons. That is why we say the total number of the neutrons and the protons will be equal to the mass number. Is it understood, Soumya?
Yes, miss.
Fine. Now, the next point is that, so let's suppose I have Z as 23, not 23, 11. I have Z as 11 and I have atomic mass, which is the mass number here, as 23. Tell me the number of electrons, protons, and the neutrons in this atom.
So there would be 11 protons and then 12
Mhm.
neutrons.
And electrons? Zero?
11. 11.
Good. Now, let's come on to the arrangement. See, the point with the nucleus is that we can have any number of nucleons. Let's suppose we are having one nucleon, okay, or let's suppose you are having 100 nucleons. All of them will have to be present in the same one nucleus. There is no maximum capacity or no minimum capacity for the number of nucleons to be present in the nucleus, okay? Okay. But when it comes to the electrons, electrons are present on the shells. Electrons are present on the shells. Each shell each shell has some maximum capacity of the maximum capacity of the electrons that it can have. Okay. Therefore, based on the change in the atomic number, my electronic configuration will change. What is electronic configuration?
The 288.
Arrangement. Yeah, good. The arrangement of electrons in the orbitals. Oh, I mean in the orbits, right? In the shells. Okay, that is the electronic configuration. So if I have different atomic number, I will have different number of protons, I will have different number of electrons. Therefore, my electronic configuration will be different. Yes. Therefore, we say that for every different element, the electronic configuration is different. For every element, the atomic number is different, and therefore, for every element, the electronic configuration is different. So, if if there are can two elements have the same atomic number?
I think no.
How do I know that atoms are belonging to the same element or they are the atoms of the different elements? How?
Because each and every single element has a different number of protons.
Good, good. So therefore, this atomic number is more of a unique identity card for every element. Each element will have a different atomic number. Each element will have a different atomic number. If you and me are different elements, both of us will have different atomic numbers. And similarly, our atoms will be having different atomic numbers. But if we are the atoms of the same element, the atomic number will be similar. Is it okay? Fine. Now,
Yes,
coming
yes.
on to the electronic configuration of the electron. What is the max? Or how many shells we have? K, L, M, N. What shell is the K shell? The first shell or the last shell? It is the first shell. The K shell is the first shell that is nearest to the nucleus. That is nearest to the nucleus. The L shell is after the K shell, the M, and then the N shell. Okay. Now, what is the maximum capacity of the K shell? Hmm.
I'm not sure.
See, how do you know the maximum capacity? By 2n square. Okay. N represents the shell number here. N represents the shell number here. Okay. Let's suppose I'm talking about the K shell. So here n is equal to 1, bache. N is equal to 1. So what is the maximum number of electrons that can be present in the first shell? Can you calculate it? 2 into 1 square. Yes. What do I get? 2 electrons. So therefore, in the first shell, how many maximum electrons could be present? 2.
Two.
Can you quickly calculate it for the second shell? The L shell,
Miss, what's
n
the
becomes,
proton number?
huh?
What's the proton number or
I'm not even
atom?
talking about the proton here. I'm just calculating the maximum number of electrons that will be present in each shell. Here we are not
For the
concerned
next
about,
one, it's eight.
huh?
Eight.
Yes, good. So in the second shell, we have the 8 as a max. What is n here? 2. Okay. In the third shell, what's the maximum capacity?
Eight as well.
Acha, 8. Okay. See, in the n shell, if we talk about n being 3, right? So 2 into 3 square, what do we get?
18.
18. But then you are saying 8. That is also correct. See, at your level, what do we do is that in the third shell, okay, we have different orbitals. We have different orbitals. We have the different subshells, D shell, S shell, P shell. Okay, so we only take it up to the 8 electrons. We do not consider the left 10 electrons. Okay, we only consider the 8 electrons maximum. Although we know that these 10 electrons are these 10 electrons can are also present in the third shell, but we only take it up to the 8 electrons. Okay, so both of them
Okay.
are correct. Actually, it is 18 electrons, but at your level, we just stick to the 8 electrons. Clear? So now,
Okay.
if I'm saying if I'm saying the atomic number atomic number for any element is 17, quickly tell me the electronic configuration.
If there's 17, is that the mass or is that the proton number?
Atomic number Z.
Atomic. It would be 287.
Excellent. 2, 8, 7. If I have it as 8, the atomic number is 8.
Just 26.
2. What is this element with the atomic number is 8?
Um, Oxygen? No.
Excellent. Yes, 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 yes. It is oxygen. Yes. What is the element with the atomic number 17?
Um,
Chlorine. Okay.
Chlorine. Chlorine,
Yes.
yes.
Now see, what does the atom want now? Each atom, I mean atoms of each element will have their own electronic configuration, right? Different from each other, different from each other. Now, what is that they want? What is that they want? How do they acquire? Are they stable here? Are all the elements stable here?
Yes.
No, not every element is stable. Every element wants to acquire stability, okay? And how do they do so? They want to acquire, they want to acquire the electronic configuration as that of the nearest noble gas. The nearest noble gas. Why? We will talk about this. There's a concept of valency. There's a concept of fully filled shells, okay? That's it. So based on that, we'll be discussing the nearest noble gas electronic configuration. Any idea regarding these terms?
No, miss.
No. Okay. So we'll just keep it very basic, very simple, so that you are able to understand the concept of the ions. That's it. Okay, and the chemical reactions. We'll not go into the details. Okay.
Okay.
Okay. But please go through the questions.
Okay, miss.
Okay. Your school is going on.
Sorry, miss?
Your school is going on, right? The school must be
Yes.
going on. Yes. When are the nearest off holidays? The nearest
Uh,
holidays that you will be having.
Monday, miss. Next week is off.
What is it? What is it on
It's
Monday?
midterm break. It's also for us to study because we have mock exams
Okay. When is your mock exam? The
in a
chemistry
month's
exam.
time.
What
Uh,
chapters coming for that?
Everything.
Everything? Are there?
Yes, everything I've learned in the past 2 years.
What chapters are all the chapters?
All the chapters that we've covered. So most of Unit 1,
Mm-hmm.
all of Unit 2, and all of Unit 4. Unit 3, it's not coming, except the first chapter.
Just a second. All of the unit one
Yes, all of the Unit 1.
and the unit two,
All of Unit 2.
unit three,
Only the first chapter.
energetics,
Yeah.
unit
And
four.
then all of Unit 4.
So we have covered all of this.
We have covered all of this.
We will be able to cover this one, and then the second unit is left. Yes.
Yes.
Hmm. Hmm.
Miss,
Hmm.
next week we can finish this chapter, and then I can start asking a few questions for revision because I've
Mm-hmm.
already started revising some of them.
Yeah. So from the first unit, and when are we going to do the second unit?
We can do that after November, when my exams will be done soon. So,
So, but your syllabus has this chapter has this unit, right, for the exams.
yes.
So then